We've talked about the different dynamic modes of an aircraft, both longitudinal modes and lateral modes. And so the next natural question would be, what are good characteristics that we would want in an aircraft? You know, what frequencies are acceptable? What damping levels are acceptable? What do pilots like? And what makes an aircraft easy to fly? What makes it hard to fly? Now, as a designer, you have control over many of the geometric and aerodynamic properties that feed into or create these different modes. And so we can control things like mass distribution, or depending on where we put lifting surfaces and how large they are, we can control the different frequencies and dampings of the different both longitudinal and lateral properties of the aircraft. And so we do have some level of control over that. Additionally, you can put what are called stability augmentation systems on an aircraft. And those are things, for example, fighter aircraft have these because they are usually unstable so that they can be more maneuverable. Stability and maneuverability usually compete. So the more stable an aircraft is, the less maneuverable it is, and vice versa. And so fighter aircraft want to be very maneuverable, and so they want to have really low stability. However, pilots still need to be able to fly them and feel like the aircraft is stable. And so they put these stability augmentation systems on the aircraft to basically actively control the aircraft so it feels like it's stable, although it may inherently be aerodynamically unstable. We've also talked about the yaw damper. So these are different control mechanisms that can be put on the aircraft to change the natural modes of the aircraft because of this additional control system. So when you put all this together, what constitutes an aircraft that has good, what we're going to call handling qualities, okay? And this was really a topic of research right after World War II, basically. As I understand it, after World War II, they shipped a bunch of aircraft out to California to what is today NASA Ames. At the time, it was NACA. But they began a big study on handling qualities, trying to understand what constituted good aircraft handling qualities. And what it really comes down to is pilot opinion, right? The pilot is going to choose whether or not this aircraft handles well or not. And that can be a little bit subjective. And so there were some early pioneers that worked on this problem. One of them was Cooper, and then later Harper helped out as well. But they came up with a way to measure or to make pilots choose this through this series of questions whether or not this aircraft had good handling qualities and be able to rank them. Okay, so we're going to talk about that today. But just here at the outset, I'd like to mention that this is a huge topic of research, and by no means is this a closed topic. This has been ongoing now for over 50 years, and there's much more to be done. And the bottom line, well, part of the point that I want to make here is that the research that has been done has been for manned aircraft. So I'll just write that down here. So for manned aircraft, we have a whole bunch of research. Like I said, the last 50 years, a lot of studies have been performed to understand handling qualities. But now, as we get into the design of future aircraft, we're talking about unmanned aircraft. And so the results that we got for the manned aircraft may or may not apply to unmanned aircraft. As we talk about things in this next section here, you've got to take this with a grain of salt, because if you are designing a drone, you may not need to match these particular handling qualities because you don't have a man in the cockpit there. And their response times are different. Autopilots can have much higher response times and can likely put up with handling qualities or degraded qualities in an aircraft, where a manned aircraft would require some higher level of handling in order to be able to complete their mission. So anyway, you just have to realize that what's going to be presented here is not necessarily something that needs to be adhered to in our modern design of aircraft. although it's a very good guide and a good starting point in the design of unmanned aircraft, but it is by no means the end all be all here. And certainly this research is ongoing, and so even the relationships that we're going to talk about here are can still be in flux. Okay, so we're going to be talking about a couple different documents here. One of those is called a military document, so it's MIL-F-8785 C, I think it's version C. That's a 1980 publication. And then another document that you might want to check out, we're actually not going to spend much time talking about it, is a military document. It's MIL-STD-1797A, and that is a 1995 document. And then there's also a book by Hodgkinson. So I'll just write that down here. Hodgkinson, published by AIAA, called Aircraft Handling Qualities. And so you can go check out that book. That book kind of summarizes what we've learned about handling qualities here. But these military documents are really are kind of the foundation of what we understand here. And a lot of this research, of course, was funded by the U.S. government, and so they published these in these documents, and which are now open online. You can go find them. At least the first one. The second one, I had a harder time finding that document online, but the first one's very simple. If you just type it into Google, and we're gonna look at that right now. So let's come over here. So this is where I pulled it down. This was just the top hit that showed up, everyspec.com. And so anyway, you can see you can just download the file there if you're interested. So we're going to come over to this document here. And this is that military specifications, flying qualities of piloted airplanes. And this document is really long. I think it's almost 100 pages long. We're not going to go through the entire document. And this just points to the fact that this is actually a fairly complicated topic. You know, an entire book has been written on this, and many other books could be written on it, I'm sure. It's a rather large topic, and we're just going to briefly go over the fundamentals here. And if this is of interest to you, then I encourage you to come back to these documents or get that book by Hodgkinson and spend some more time studying it. And of course, Phillips in his Mechanics of Flight book has a very nice overview of the same topic here. So let's come down here and talk about a couple things. So first of all, they found when they started to get pilot opinions that it depended on what kind of aircraft they were flying, right? So just the same way that probably you would rate the handling qualities of a bicycle different from an ATV or something. It depends on the type of thing that you're flying, because you have certain expectations of what that should be able to do because of its size or whatnot. So, you know, if you some automobile may have really good handling qualities on the freeway, for example. You know, maybe you're driving a semi on the freeway and you think, hey, this handles great, but then you're asked to do some parallel parking in a city, and you recognize that it's really challenging with this particular automobile. So they found the same type of thing here, and so what they ended up doing is classifying these aircraft into a couple different classes here. So we're just going to talk about what those are, and I'll just read through these. So class 1 is small light airplanes, such as light utility, a primary trainer, or a light observation. They would come down here. Class 2 is a medium weight aircraft, low to medium maneuverability airplanes, such as heavy utility, search and rescue, light or medium transport cargo tanker, early warning, electronic countermeasures, airborne command, control, or communications relay, anti-submarine, assault transport, reconnaissance, tactical bomber, heavy attack, or a trainer. So, of course, there are some aircraft that are just trainers for these classes of aircraft, and so, of course, a trainer for this class would also fall under that class. Class 3 are large, heavy, low to medium maneuverability airplanes, such as heavy transports, cargo tankers, a heavy bomber, patrol, early warning, electronic countermeasures, airborne command, control, or communications relay, or a trainer, of course, for Class 3. And then Class 4 are high maneuverability airplanes, such as fighter, interceptor, attack, tactical reconnaissance, observation, or a trainer. Okay, so these are the four different classes of aircraft, and so you'll see those referred to throughout this document. You know what class of aircraft they did handling qualities on these different airframes, and so you know you have certain rules that certain classes of aircraft need to abide by, where others have different rules that they need to abide by, and then some rules are abide to all the different classes of aircraft. Okay, the next thing they also found was that it depended on so pilot opinion depended on what they were asked to do. And so they've divided these up into what are called flight phases. And in this document, they're divided into non-terminal and terminal flight phases. So first we'll talk about the non-terminal flight phases. So the first one is called a Category A. These are non-terminal flight phases that require rapid maneuvering, precision tracking, or precise flight path control. Included in this category are air-to-air combat, ground attack, weapon delivery and launch, aerial recovery, reconnaissance, in-flight refueling, terrain following, anti-submarine search, or close formation flying. Okay, then Category B. So this is a different category of flight phases or things that they were asked to do. Again, non-terminal. So these are flight phases that are normally accomplished using gradual maneuvers and without precision tracking. So the other Category A is rapid maneuvering and precision tracking. Okay, so that's a big difference here. So from some examples here are climb, cruise, loiter, in-flight refueling for the tanker. The other one was for the receiver. Which requires much better maneuverability. Descent, emergency deceleration, and aerial delivery. Okay, and then there are terminal flight phases. So these are Category C. These are normally accomplished using gradual maneuvers and usually require accurate flight path control. So gradual maneuvers, but accurate flight path control. Because these are terminal, you're interacting with the ground here. So we have takeoff, catapult takeoff, approach, wave off, go around, and landing. Okay, so they found that pilots' opinions depended on not only what aircraft they were flying, what class of aircraft, but what they were asked to do. And so we have these three different categories of flight phases or things that they were asked to do. Okay, so now these pilots. What they tried to get was a handling quality out of them, which they would then rate as level 1, level 2, or level 3. And before we talk about this, I'm going to flip over to the Cooper-Harper rating scale. So this is something that was developed by these pioneers in this field of handling qualities. And you can read about this on Wikipedia, but this is kind of the graphic that most people might be familiar with here on handling qualities. So this is what they asked each pilot to do. So they would ask them in a specific aircraft to perform a certain maneuver, and then the pilot was forced to go through this decision process here, where they had to say yes or no to several questions here, and the way that they answered then would determine the handling qualities of the aircraft. So for that particular situation, right? So we start in the bottom left here. So the pilot comes in and is asked, is it controllable? Well, if it's no, if this is not controllable, then of course improvement is mandatory. There are major deficiencies, and you can just follow that arrow over. Control will be lost during some portion of the required operation. And so this is a pilot rating of 10. So we're going to have 10 different levels of rating here that these decisions are going to force us into. And then eventually these ratings get lumped into level 1, level 2, and level 3, and kind of unofficially level 4. Okay, so we talked about level 10 there. That first question is it controllable? No, then it's level 10. If yes, it is controllable, then we go on to the next question here. Is adequate performance attainable with a tolerable pilot workload? Okay, if no, then these deficiencies require improvement, and then the pilot would be asked, are these major deficiencies? Well, all of these major deficiencies, I'm sorry, the next column over, then they could choose out of these three options to put it as a 7, 8, or a 9, okay? Okay, let's keep going up the chain on the left-hand side. So first we asked, is it controllable? If yes, then is it adequate performance attainable with a tolerable pilot workload? Yes, then we move up the chain. Is it satisfactory without improvement? Are you satisfied with this? And, they may not be satisfied. So if it's no, then these deficiencies warrant some level of improvement. And so these are, you can read that next column over. These are minor but annoying deficiencies, and they would be then ranked into 4, 5, or 6 by these categories here. And then finally, if it passed that very last question with a yes, is it satisfactory without improvement, then the pilot was still asked to rank it between 3 levels here, which is an excellent, highly desirable, good with negligible deficiencies, or fair with some mildly unpleasant deficiencies. And so then that would give it a pilot rating of 1, 2, or 3. Okay, so we have these 10 different levels. Now, 10 levels is rather difficult actually for humans to think and to make a decision and rank something from 1 to 10 very accurately. But this outline here is what was used and come up with to get the pilots to be able to do that. And then we basically say that if it's a pilot rating from 1 to 3, we're going to call those level 1 handling qualities. And if it's a pilot rating 4 to 6, we're going to call that level 2 handling qualities. 7 through 9, that's level 3. And then, level 4, we really don't talk about much because these are major deficiencies. This is an uncontrollable situation. And so level 10 here, or pilot rating of 10, is kind of an unofficial level 4. But anyway, the levels 1, 2, and 3 are pretty standard and match these other categories quite well. So this image you can find on the internet, different places. This particular one, I probably need to thank whoever developed it and put it here on Wikipedia, but you can just go onto Wikipedia and study it in more detail. There's also a remake of this image in Phillips's textbook. Okay, so these pilots then would return with this level 1, 2, or 3, and then and so that's what these are right here, level 1, 2, and 3. And so just to summarize, level 1 is flying qualities clearly adequate for the mission flight phase. Flying quality level 2 is flying qualities adequate to accomplish the mission flight phase, but some increase in pilot workload or degradation in mission effectiveness, or both, exists. And then level 3, remember that was 7, 8, and 9 of the pilot rating. Flying qualities such that the airplane can be controlled safely, but pilot workload is excessive or mission effectiveness is inadequate, or both. Category 8 flight phases can be terminated safely, and Category P and C flight phases can be completed. Okay, so these are 3 different levels, and of course what we want to be is level 1. Now you can't just stamp handling quality on the side of an aircraft and says this has level 1 handling qualities, because it depends on that level 1 is associated not just with that aircraft, but it also was associated with a specific task that the aircraft or that the pilot was asked to do, and with a specific pilot who was asked to do that task. Because of course you have to be a trained pilot to even do these tasks in the first place, and to be able to even expect something out of this aircraft or have some level of expectation of how it should handle in that situation. So these handling qualities depend, of course, on the aircraft, on the pilot, on what they were asked to do. And so they had a whole bunch of data that they then pulled together and correlated to come up with suggestions for what the longitudinal modes should be in order to produce desirable handling qualities. Now, a lot of this work was, so like I said, they took a bunch of World War II aircraft and studied those. And I just want to mention a couple other ways that they studied this particular problem. One of those is through flight simulation. So it's a lot easier to put a pilot in a simulator and to change the qualities of that aircraft. You can change actively the damping derivatives, the aerodynamic derivatives, stability derivatives, control derivatives, inertias on the aircraft. All of those things can be changed very quickly in the simulator, and you can repeat a mission over and over, or some task over and over, like takeoff or landing, and get a lot of data and figure out exactly where the line is, so to speak, of degradation. You know, how the handling qualities are going to change as you change these different properties of the aircraft. So they did a lot of that in flight simulation. That's a lot cheaper. Then you're not sacrificing an aircraft if something goes wrong, and of course the time in the air is much more expensive, pilot time and getting the aircraft in the air. So flight simulation, they did a lot. They did do some real flight testing, and then or quite a bit of flight testing rather, and then I also want to mention this interesting aircraft. So this is the Convair NC-131H. This is called a total in-flight simulator. So they called it TIFS, TIFS. And this is a very interesting aircraft, because what they did with this was they were able to modify the aircraft so that it actually had flying qualities of a different aircraft. So they would add things. For example, you can see in these images here, these vertical fins out on the main wing. You can see those. And maybe I'll get a better picture here. There it is up close. But anyway, they would add things to this aircraft to make it act like a future aircraft that was in development or something, or be able to measure the pilot's response and what they thought about, how this future aircraft might handle. And so anyway, they called it this in-flight simulator because they could simulate different aircraft and how they would handle in a real flight scenario. So, for example, on this website, so this is the U.S. Air Force Museum, and that's in Dayton, Ohio. A fantastic museum if you haven't been there. Huge, and this aircraft is sitting there in the museum, so you can check it out. But anyway, this aircraft was you can see on their page here. They list the aircraft here in this third paragraph down. That this was designed to mimic a few other aircraft that you might recognize. So the X-40 Tassat Blue, that's kind of a lesser known aircraft. The Space Shuttle, B-2, the YF-23, C-17. So these are a few of the aircraft that you might have recognized there, but they were able to make this aircraft basically handle in flight like those other aircraft would, and so pilots could give their feedback early on in the design process of these aircraft, so they could see if they were going to have an issue with handling qualities. Okay, so anyway, this is just an introduction to handling qualities. Again, this is a huge topic, and for example, if I just scroll down here, there's a lot of other things that this covers. So let's see, external stores, state of the airplane. Let's come back to that in just a second. Service flight envelopes. Let's see. Okay, it talks about maximum service speed, minimum service speed, altitude, service altitudes. Let's see. Okay, normal states. We're going to come back to that in just a second. Normal and failure states. Okay, and then we're going to get into longitudinal flying qualities. So in the next video, I'm going to talk about what they found longitudinally, and we'll look at actually frequencies and damping and things of the longitudinal modes. But one last thing I want to talk about here is failure state. So, and I'm just going to switch back over here. So let's talk about failure states here. So of course, we want level 1 handling qualities if we're in what's called a non-failure state, okay? And so that's it's called a normal state. If you don't have any failures on the aircraft, that's called a normal state, and we would want level 1 handling qualities. Well, they actually allow handling qualities to degrade if you have a failure on the aircraft, but the amount of degradation depends on how often that failure might happen. So, for example, any failures that could happen one in every 100 flights, they allow a degradation to level 2 handling qualities if that happens during that flight. But if the and then if there's a chance that it'll only happen in 1 hour out of every 10,000 flights, for example, then they'll allow level 3 handling qualities if that thing were to fail. So you have to look at the different failures on an aircraft that might happen. If the yaw damper goes out, for example, that's a failure. If an engine stops working, that's a failure. If a control surface gets stuck in one position, that's a failure. You can have something in the hydraulic system or whatever that would freeze that up, or something in electronics. So anyway, you have all these different failure states of the aircraft, and so what we'd need to study then is what are the handling qualities if that mechanism fails, or if we're in that failure state. What are the handling qualities that we're going to have, and how often do we think that that's going to happen? Probabilistically, how often would this or could this happen? And so anyway, these are some of the things that you have to think about. And then also they allowed lower handling qualities when you hit turbulence. So if you have moderate turbulence, they allow you to go down to level 2 handling qualities in some situations. And then if you hit severe turbulence, sometimes you're allowed to go down to level 3 handling qualities. So anyway, these are just some other things to be aware of, that we shoot for level 1. But there are scenarios where these lower level handling qualities are allowed, but they're things that we hope don't happen very often, obviously, throughout the operation of this aircraft. Okay, so we're now going to move into the actual results that they got, and we'll study those for both the longitudinal and the lateral modes.